So today we are going to solve grid paths 1. So in this question, consider an end-to-end grid whose squares may have traps. It is not allowed to move to a square with a trap. Your task is to calculate the number of paths from upper left square to lower right square. You can only move right or down. Okay, so what we are given here, we are given a grid of n into n cross n grid we are given. And what we have to do is we have to find how many paths are there to reach from here to here, start to end. That is upper left corner to bottom right corner. And we are also given that in some spaces there are obstacles, so we can't move from there. So that is our question. Let's look into sample. We are given 4 into 4 matrix, and this is what we are given, 4 into 4 matrix. So if we start from here, then we have to find how many ways we can reach here. So like this can be one way, this can be one way, this can be way. Now there is a condition we can only move to right or to bottom. So how can we do it? Suppose we are at position I comma j and we have to find how many ways are there to reach the bottom. Okay. So what are the ways we can move? We can go towards I plus 1 comma j and I comma j plus 1. Okay, so there are only two ways. So suppose if we know the answer of I comma I plus 1 comma j, and if we know the answer of I and j plus 1, then we can find out the answer of I and j. It would be I plus 1 comma j plus answer of I and j plus 1. That is what DP is. Like we know a problem and we can convert it into a subproblem. Now, if we know the answer of this and this, we can easily find the answer of our required case. Now, what would be our base case? Base case is means what are the base cases which we know that this would be the answer. Suppose if we are at n comma n, we definitely know that there is only one case because we can reach it. So try to visualize it this way. Mm. Let us go with the recursion first. Okay, so we have to find for I comma j. And yes, we have to find for I comma j. Now, if I goes out of bound or j goes out of bound, or if we cannot move to that box because there is a obstacle there. Or corridor I comma j is equal to obstacle. So in that case, we would return 0 because there are no ways. Now, if we reach the last box, that is I equal to n and j is equal to n. So we know that this is our, we have reached the destination, so we can return 1. Okay. Now, what would be our answer? Answer would be solve of I plus 1 comma j plus I comma j plus 1. And return answer. Now, what is the thing which is remaining here? That is memoization, because we are repeating many states in the process. Suppose we are here and we have to find this. We find this, and when we are finding for this also, then also we will require this case. So we can simply memorize it. You know the process of memoization. If we already found that, if we have already visited that state, then we will repeat directly it, or otherwise we would store it, then return it. So what is happening here? Suppose this is the group. Suppose it is a 5, 5 grade. Now, if we start from here, if we start from here, then there is only one way from where we can reach here. Okay. Or if we want to, if what is happening here, actually, what we did was we feel that this is one. From here, from n comma 1 and to reach n comma n, there is just one way. Now, if there is one way here, then from to reach here, this is also one. To this is also one. But this would be 2, because we can go from this case also and this also. Similarly, for this would be 1, 1, 1, 1, 1. From here, we got 3 ways, because we already got 2 ways for this and 1 ways for this. So we can go from here, here, and here. So it would be 3 case. Similarly, this would be 4, this would be 5, this would be 3, this would be 6, 10, 15, 4, 10, 20, 35, 5, 15, 35, and 70. Now, because of the obstacles, there would be certain paths where we cannot visit. Suppose in the grid here, it is an obstacle. So we cannot visit this, so it will become 0. Now, because we can't visit it, it would become 0 and it would also become 1. So that is how the problem changes by adding just an obstacle. So if we look for a tabular way, where we can start from. Suppose we are starting from, we can always do from here also. Like how many ways are there to reach here? If we change our definition, in this case, what is our definition? For this TP, I comma j will give us number of ways if we start from here. Now, if we change it to number of ways to end here. Now, if how many ways are there to reach to end to reach here, not to reach n comma n from here. What are the number of ways to reach here from 0 comma 0? So it would be dp of I comma j would be simply I minus 1 comma j plus I comma j minus 1. You understood how I changed a definition a little bit. So now what we are doing, we are calculating it forward. Like forward means it would start from here 1, here also, sorry, 1, 1. Here it would give 2, 1, 3. Here also 3, and here 6. So if we are now, let us go for iterative loop. 0 comma 0. To calculate a step, we required it's I minus 1 and j minus 1. So that's why we are going from I 0 to n minus 1, because whenever we are calculating any specific I, we would require its previous I. So that's why we are going from 0 to n. And for j also, that is the similar case. So that's why for j also 0 to n. Now if I minus 1 if this box has an obstacle, then we can't reach here. So we would continue. Okay. Now if there is a previous block, then it would equal to dq of I minus 1 j. If its upper position is also available. Okay, and that's it. We would return dp of n minus 1 comma n minus 1. And we would also define our base case dp of 0 comma 0 equal to 1. So now this would return us our answer. I hope you are getting. So let's talk about time complexity. That could be n into n because we are just iterating every block of the grid. So it is n comma n, there are n comma n, n, n into n blocks. And space complexity would be also n into n because we are required to calculate dp from n into because we are calculating dp of every block. So space complexity would also be n into n. Now we can also improve the space complexity to only n because see here each time we are just require the previous block. Suppose this is the dp of I and this is dp of I minus 1. So at every point we only require its previous array. We don't require dp of I minus 2, dp of I minus 3. We don't require these blocks. So what we can do, we can simply instead of creating a dp vector of n comma n, we can just create a dp current of n and dp previous of n because we just require two columns for every. And whenever we are done calculating the answer for the current dp, then there is no use of previous dp. So we would simply swap this. So for next iteration, the current dp would become previous dp to calculate the new dp current. So this way we can improve our space from n into n to n. Although it is not required in this question, but in some questions there is a space. There is some space constraints also, so it would be required there. Here it is only 1,000, so it would not be required to uh, optimize the space. But this is just some one of the methods to optimize the space. Now let's code. We are given and now what we have to do. We would create for long. I think int is also fine. We are printing the modulo. We would do modulo with every operation. dp current, comma, dp previous of that. What will be our dp of I? That would be ways to reach I of current layer. Base case dp of current, the current of 0 would be 1 because for our vector for our grid the first element has one way. We also have to take input of the grid. Grid of I comma j is stable, then we will continue. If we can reach its previous I. Then dp current of j is plus equal to dp. Actually, this is not required because dp previous of j and dp current of j is equal to dp current of j minus. Now we also have to do mod ten power 9 plus 7 dp current of j. Now after every layer we will swap dp of current with dp of previous. We would also require to clear the dp. So instead of that, we can just declare it here. Change the dependency. Now we have previous and minus 1. Okay, so we got our answer. Sorry. Let us check if it would give us integer overflow. In CP, every wrong submission counts. So we have to be sure. Practice for that also, that you do as much as you submit when you are 100% sure only. So this would maximum value can go till less than 10k power 9. I think it should work. Let us hope. So as you can see, we got accepted. Thank you guys. See you in the next video.